Welcome back, everyone. We're diving into quantum physics today. Specifically, there's this new way of teaching it, and it's causing a real buzz.
Yeah, I've been following that too.
We found this really cool article about it on scitechdaily.com. A lot of people find quantum physics pretty intimidating,
Right.
but this new approach could be a game changer.
It really could. Even the American Physical Society is paying attention to it.
I know, right? It's a big deal. And what's fascinating is how different it is from the traditional way of teaching it.
Definitely. Usually you start with all the history.
Right, all the historical background.
Which is important, don't get me wrong, but
Sure.
it can get pretty overwhelming if you're just starting out.
Totally. It's like, where do you even begin to unpack all of that?
It's almost like trying to learn a new language by starting with its ancient roots.
Ooh, I like that analogy.
You need the basic grammar before you can appreciate the poetry,
Exactly. You need that foundation. So this new method, it focuses on two-state systems. Have you heard about this?
Oh, yeah.
What are those exactly?
Well, think of a qubit. It's like the simplest quantum system.
Okay, a coin.
Imagine a coin. It could be heads or tails, right?
Yeah,
But not both at the same time.
got it.
That's basically a two-state system.
Okay, so how do these coins fit into the bigger picture of quantum physics?
It's pretty amazing, actually. These simple systems, they're like the building blocks of all this incredibly complex technology, like quantum computers
Oh, wow.
and cryptography.
Quantum cryptography, that sounds super high-tech, like unbreakable codes, right?
Exactly. It leverages these quantum mechanics principles to secure communications. It's like in the quantum world, just observing a system changes its state.
Whoa.
So if someone tried to eavesdrop, they'd leave a trace.
Oh, so they couldn't get away with it.
Nope. The sender and the receiver would know.
That's incredible, like a built-in security system.
Yeah.
Okay, but going back to this new teaching method, why are these two-state systems, or qubits, so important for understanding all of this?
Well, they give you a really intuitive entry point into some of the most complex concepts. You're not getting bogged down in historical details.
Right.
You start with these basic building blocks.
It's like learning the ABCs before you can write a whole book.
Precisely.
Is there any research out there that shows that this is actually a better way to learn?
Absolutely. Professor Philipp Bitzenbauer and his team, they found that students who learned this way developed a much deeper understanding.
Wow. So there's real evidence to back it up.
Yeah. And you know what? He's actually presenting these findings at the APS Global Physics Summit in 2025.
A global physics summit.
That's a pretty big deal. And guess what? That's the International Year of Quantum Science and Technology.
No way. So it's perfect timing.
Yeah, I think it's a really exciting time to be talking about all of this.
So what you're saying is, by understanding these simple systems, we could potentially revolutionize technology as we know it.
Exactly. And it's not just theory. This focus on two-state systems is directly tied to the advances in quantum technology that we're seeing right now.
Like quantum computing.
Yeah.
That has the potential to change everything, right?
It really does. Think of it this way. Quantum computers are essentially built by manipulating these qubits.
Okay.
The potential is enormous. I mean, imagine being able to solve problems that are just impossible for regular computers to handle.
That's wild.
Things like instantly factoring massive numbers,
Wow.
which has huge implications for cybersecurity, or like simulating super complex molecules.
Which could lead to...
All kinds of breakthroughs in medicine. I mean, the possibilities are pretty much endless.
That's mind-blowing. But how do we actually control these qubits? I mean, they're subatomic particles, right?
Yeah.
How do you even manipulate something that small?
That is a great question. And it really highlights the ingenuity behind what's being called the second quantum revolution. Yeah. We've developed some pretty sophisticated techniques to isolate and manipulate these particles and even entangle them.
Entanglement. Okay, now that sounds like something straight out of a sci-fi movie.
It kind of is. It's one of the most bizarre and fascinating things about quantum mechanics.
So what is it?
Imagine, like two qubits, no matter how far apart they are, they're linked
Okay.
and they share the same fate. So if you change the state of one,
Yeah.
the other one changes instantly, even if they're like light years away.
Whoa, that's crazy.
Right. It seems to defy all the rules of classical physics.
It's like they have this, like, telepathic connection or something.
Exactly. It's like they're communicating instantly across vast distances.
How is that even possible?
Honestly, we don't fully understand how it works, but we know it does. And this entanglement thing, it's what's driving a lot of the power behind quantum computing and communication.
So by harnessing that, we can create these super powerful computers and these ultra secure networks. It feels like we're just scratching the surface here. What else can we do with this kind of technology?
Oh, there's so much more. It's like we've stumbled upon this hidden layer of reality where the old rules don't apply anymore.
Wow.
And this new way of teaching quantum physics with a focus on qubits, it's like giving us the tools to explore and understand this strange new world.
Okay, so I think I'm starting to get it now. By understanding these simple building blocks, the qubits,
Yeah.
we can then grasp those more complex ideas,
Exactly.
like entanglement and superposition,
Right?
and ultimately unlock all this incredible potential of quantum technologies.
You got it. It's like you need that alphabet before you can write a novel.
Well,
And the novel we're writing here, it's a whole new chapter in human history.
that's a powerful way to put it. It's pretty amazing to think that we're living through this moment, witnessing this new technological era being born, and it all goes back to those two-state systems.
It really does. What I find really exciting is that we're just at the beginning. I think as more researchers embrace this new way of teaching quantum physics,
Yeah.
we're going to see a burst of creativity and innovation.
I can't wait to see what comes next. It's a really fascinating time to be talking about this. But before we get too far ahead of ourselves, can you give us some real-world examples? Like, how is this two-state system approach being used right now in research and education? What are some of the projects that are already making a splash?
Oh, absolutely. There's a lot going on. Well, one area that's really exciting is quantum simulation.
Quantum simulates.
Yeah, so these are like specialized tools that use qubits
Okay.
or two-state systems, to model systems that are way too complex to study directly.
So, like, instead of trying to observe, like, how molecules behave in a material,
Yeah,
we can use qubits to create a sort of mini version of that.
exactly. It's like having a quantum sandbox
A quantum sandbox.
where researchers can like tweak things and see what
It's
happens.
so cool.
Yeah, and it's already providing insights that we just couldn't get before.
So what kind of things are they studying with these simulations?
Oh, wow. The range is incredible.
Yeah.
Everything from superconductivity to like the properties of new material.
It's amazing how quantum physics is becoming more hands-on.
Right.
It's not just about equations anymore.
Yeah, and I think this two-state system approach is a big part of that.
Because it's more about understanding how these systems actually work.
Exactly. It's not about memorizing formulas.
Right.
It's about developing an intuition for how things behave.
Which then gives us the power to, manipulate them and create new technologies.
Absolutely. It's like this chain reaction of understanding and innovation.
But, with all this talk about the potential of quantum technology,
Yeah.
we have to think about the risks too, right?
Oh, absolutely.
I mean, these are powerful tools.
Very powerful.
We need to be careful about how they're developed and used.
We need to have open discussions about the ethics involved.
Yeah, involving scientists, policymakers.
Everyone.
The public too, right?
Absolutely. This is a future we'll all be sharing.
It's a lot to think about, but it's also really exciting. It feels like we're at the start of something huge.
Yeah.
Like we're moving into a new era where quantum mechanics is actually shaping our world.
And to think it all started with these simple two-state systems.
It's true. Sometimes the most complex things can be broken down into these really manageable pieces.
Exactly.
It's actually kind of empowering.
It is.
It means that anyone can understand these ideas, even if you're not a physicist. It's like we're getting this glimpse into a whole new world,
Yeah.
but we're just at the beginning, right?
Oh, yeah.
What other surprises are waiting for us in the quantum realm?
Well, there are definitely more mysteries to uncover.
Like what?
As we go deeper, we're going to find even more things that challenge our understanding of reality.
It's kind of mind-blowing, isn't it?
It is. That's what makes it so captivating.
I'm starting to get hooked on all of this.
I can...
It seems like those two-state systems, they're everywhere.
Yeah.
Like the on-off switch on my coffee maker.
Right.
Or the code running on my computer.
It's like this hidden language.
Yeah.
It's all around us.
Or like the quantum world is suddenly coming into focus.
That's the power of knowledge, you know?
Yeah.
It changes how we see the world.
Well said. So as we wrap up this deep dive into quantum physics,
Yeah.
what's the one thing you want our listeners to really think about?
I'd say the main takeaway is that quantum physics is not some super complicated thing.
Okay.
It's becoming more and more relevant to all of us.
And more accessible, too.
Exactly. And with this new approach to learning,
Yeah.
We can all be a part of this quantum revolution.
I love that it's like a call to action.
It is.
So to our listeners,
Yeah.
keep exploring the quantum realm. Dive into the things that fascinate you.
Let your curiosity lead the way.
You never know, you might make the next big discovery.
You might.
And remember,
Yeah.
the universe is full of wonders just waiting to be uncovered.
All you need is an open mind.
And a sense of adventure.
And a willingness to embrace the unknown.
Exactly. On that note,
Yeah.
we'll say goodbye for now.
But keep exploring.
Keep asking questions.
And keep diving deep.
This is just the beginning of an amazing journey. It feels like we've only just scratched the surface here.
We have. There's so much more to explore.
So where do we go from here? What are the biggest hurdles researchers are facing?
Well, one of the toughest challenges is scalability.
Scalability.
Building these quantum computers with lots of qubits.
Okay.
It's incredibly difficult.
I can imagine.
These systems, they're so sensitive to anything.
Right.
Maintaining those quantum states, it's a huge engineering feat.
So it's not just about adding more qubits.
No, it's about making sure they all work together.
Like a well-oiled machine.
Yeah, but way more delicate. It's like, imagine trying to build a house of cards in a hurricane.
Oh, wow.
Even the tiniest disruption can mess everything up.
So how are they tackling that?
Researchers are trying different things, like building more robust qubits.
Okay.
And finding ways to protect them from interference.
Like shielding them from the outside world.
Exactly. It's a real balancing act.
Between pushing the limits of what we can build and understanding the very nature of these quantum systems.
Okay.
So what kinds of qubits are they working with?
There are a bunch of different types,
Mm.
each with pros and cons.
Like what?
Superconducting qubits, they use electrical circuits that work in this quantum way, but only at really low temperatures.
Oh, wow.
Then you have trapped ions, where they use lasers to control single atoms in a vacuum.
It's like a race to see which technology will win out in the end.
It is, in a way. But the thing is, different qubits might be better for different jobs.
So we might end up with a bunch of different quantum technologies.
Yeah, each one designed for a specific task.
It's mind-blowing to think about what we could achieve.
It is.
I mean, we could have computers that can crack any code, simulate molecules perfectly, leading to all sorts of breakthroughs. What else are people excited about?
Quantum sensing is a big one.
Quantum sensing.
So we can use the sensitivity of these quantum systems to build sensors that can pick up the faintest signals,
Okay.
like gravitational waves or even the magnetic fields from individual brain cells.
Wow, that's incredible. It's like we're gaining a whole new way of perceiving the world around us. This deep dive has really changed how I think about quantum physics.
I'm glad to hear that.
It's not this scary, incomprehensible thing anymore. It's a field that's full of possibility.
Exactly. It's a testament to how powerful this new teaching approach can be.
It really is. So as we wrap up our exploration of all things quantum,
Yeah.
what's the one big takeaway you want our listeners to remember?
I think it's this. The quantum world isn't some far-off place.
Okay.
It's all around us. It makes up reality itself.
And by being curious and open to learning,
Yeah.
we can all be a part of this quantum revolution.
Well said.
To everyone listening, we hope this deep dive has sparked your own curiosity about the quantum world.
Keep those questions coming.
Keep pushing those boundaries of knowledge.
And who knows? Maybe you'll be the one to make the next big discovery.
Until next time, keep diving deep.